So what we're going to learn is something called inverse of a matrix. Inverse of a matrix. Today, this video will just cover a 2 cross 2 matrix. Right? Only a 2 cross 2 matrix. So the idea is, how do we find the inverse of a 2 cross 2 matrix? But just before that, can I find the inverse of any matrix? No, I can only find the inverse of a square matrix. And 2 cross 2 is obviously a square matrix. So first of all, let's define any matrix A, and I'll just hypothetically put a figure, matrix elements here. So I'll say 2, 3, 1, 6. Okay. Now this is a matrix for which I'm going to find the inverse. So the first and foremost step that I need to do is, or the precondition for an inverse of a matrix to exist, is find its determinant. Determinant determines whether the inverse of a matrix can be found or not. How do I find the determinant of a 2 cross 2 matrix? So what I do is I pick up the elements on the leading diagonal here and I multiply them, and I say 2 times 6. 2 times 6. Take away the elements of the other diagonal, 3 cross 1. I'm trying to find the determinant here. Determinant is, so determinant determines whether the inverse of the matrix will exist or not. Let's try to solve it. But then the question is, how do this really determine? Let me quickly solve this. This is 12 minus 3, so the determinant is 9. Now the rule says that if your determinant is not equal to 0, then the inverse of a matrix exists. And we'll see why. Inverse of a matrix exists. If determinant is equal to 0, inverse does not exist. Easy so far? Now here in this case, I know my determinant is 9, so that means it is not equal to 0. Now this could be a negative number as well. I don't care, because even the negative number is not equal to 0, even then the determinant will exist. Right? So in this particular case, I say my determinant exists. Once I have found that the determinant exists, I move forward, and now I will go and find the inverse using this determinant. But then if I would have hit a determinant equal to 0, I would have just stopped there and I said, no, can't proceed, inverse doesn't exist, period. End of the story. In this case, it is 9. So I move ahead to the next step, finding the inverse. So now step 2 is, now I write the same matrix back, 2, 3, 1, and 6. I swap the elements of leading diagonal. And I place a negative sign in front of the elements of the other diagonal. Let's form that new matrix, the transformed matrix. So now my matrix would look something like this. Your leading diagonal elements are swapped. So 6 is swapped by 2, and this is how it will look now. And a negative is placed against the elements of the other diagonal. So if this is a 3, it becomes a negative 3. If this is a 1, it becomes a negative 1. Suppose you would have a negative against your elements in the other diagonal, then placing another negative in front would have turned into a positive. So always take care of that. So once I've formed this new transform matrix, I do my last bit of magic where I use this determinant. So what I do is my step 3. I divide my new transformed matrix by the determinant. You see here. One over D. So that is my A inverse. So what it actually means is my inverse was not, my determinant was 9. So I'll say 1 over 9 and all of that 6, negative 3, 1 and 2. And then I just solve it. So if I quickly go to the next page and find the final inverse of a matrix, it is 1 over 9, 6, 2, negative 3 and what? Negative 1, right? That's what we have. So my A inverse is 6 over 9, negative 3 over 9, negative 1 over 9, and 2 over 9. If anything I can simplify, I should. 6 over 3 is what? 2 over 3. 6 over 9 is 2 over 3. This is negative 1 over 3. This is negative 1 over 9. This is 2 over 9. That is the A inverse. That is how you find the inverse of a 2 cross 2 matrix. It's as simple as that.